So I'll share my screen. And I will also record the session. Okay. Can everyone see my screen?
Yes.
Wonderful. Thank you.
Yes, correct.
Okay. Welcome to all of you. Welcome to this monthly seminar of the SDGs and Global Sustainable Futures, a workshop organized at the occasion of 9th session of the Global Sustainable Futures Progress Through Partnership Network. Welcome to all of you. Good morning, good afternoon, and good evening from wherever you are joining me today in this Zoom meeting and setting. And so just a technical remark that to start off, please, everyone keep your camera on if you wish, but do switch the microphones off until you are taking the floor. Also, please note that this is a public event and it is being recorded while we are also on live on our YouTube channel. So please be aware of this. So I would like to first of all thank that this in-kind support given by UCEM, my university, to support this Zoom platform and allow us this seminar. I would also like to acknowledge and thank all my champions of this network who are supporting in various essential jobs, such as keeping the coordinator list up to date, and also posting on social media and engaging with various research and other events. I would like to thank all of them at the outset for helping us to organize and to help this seminar, plan this seminar. And we also have an excellent panel with us today. And I will introduce the panelists just in a minute when they are before the start of the meeting. And we will bring you, I will bring you to the speed with the network's ongoing activities. Today we have an interesting intervention in our seminar, and that is with the Axis app, which is to make our meeting matter. And this will be introduced by Matt Castle from Axis Workshop Limited. So again, welcome to all of you, my fellow network coordinators who have joined me today and who will listen this recording later. And I wanted you to just tell about this monthly seminar and this network itself. So here, for those who have joined it today and for the first time this seminar, I'm Dr. Renuka Thakur, founder of the Global Sustainable Futures Progress Through Partnership Network. As a researcher, I identified a need for research collaboration between the Global South and Global North, and between and beyond low, middle, and high income countries to secure global sustainable futures, and which are more important than ever. So I committed to create this collaboration, or you can say partnership, across national borders and academic disciplines, and made a formal start to this grant and innovative initiative through a kickoff meeting on October 30, 2020, with just coordinators from 27 countries. So through the Global Sustainable Futures Progress Through Partnership Working Group, we want to play a leading role in creating an inclusive, collaborative, innovative, and engaging platform for early career researchers and like-targeted stakeholders, including startups and entrepreneurs, supported by experienced senior researchers and business leaders where everyone can share in their research, innovation, visualization, and enthusiasm in parallel to network success. And the network success lies in achieving our fundamental objective, which is to create a strong research environment, building to a multidisciplinary and multi-sectoral team of endogenous professionals that would be capable of pursuing and utilizing participatory and integrated approaches in solving public and environmental sustainability problems. And therefore, our priorities are empowering and capacity building, fair and those activities which we are delivering and we are involved in, we want to become fair and inclusive, not only in just numbers or gender, but we want to also improve economic, social, and environmental equality and fair distribution and access of good quality life and working condition. Above all, we want networking and engagement, providing this innovative and global-wide platform, and spatially and in particular, overall umbrella of sustainability, that is co-creating sustainable and resilient development pathways to secure sustainable futures for all and everyone. And so the key focus is to increase mobilization and engagement, building a community of practice, creating a strong leadership, and producing a critical mass of practices. So we do three main activities. Daily, we try to engage with the UN Global of Month through social media, simultaneously engaging with other formal and informal networking events. Monthly, we have these, which we have today, seminars, engaging with strategic and emerging global debates, while the monthly seminars serve also as networking and capacity development platform. And then we have projects with engaging with global issues with targets to one or more sustainable development goals and beyond. And so we committed to investigate what needs to be changed and to initiate projects important to build a sustainable society, to act as ambassadors of SDGs and contribute to research activities of one or more SDGs, to engage with various relevant stakeholders to step up, join forces and build a stable network, to having strong mission and mission-oriented approach, and to go beyond and establish concrete examples of co-created and co-designed solutions. So I will start with a quote of the month by Penmao Zhai, co-chair of IPCC Working Group. Climate change is already affecting every region on Earth in multiple ways. The changes we experience will increase with additional warming. And so I think it is very, very important that we share our knowledge through this platform in more constructive way to the external world. And we need collective voices. And so we need to engage with the discourse of this climate change and sustainability as much as we can. So let me start with introducing you to the UN goal of the month. Goal of the month September 2021 is about 8 things to look out for the General Assembly this month. And this is like SDG Moment, which is going to be on 20th September. Look at the launch of the Keeping the Promise campaign through global goals. They will also look at the Durban Plus 20 to fight racism. So Food System Summit will be there on 23rd September. And Interspecies Assembly is between 21st and 24th of September. High-level dialogue on energy is on 24th September. So last month, it was the goal of the month was on energy, SDG 7. So you need to engage with that still. And the SDG Media Zone at UNGA will go live from 16 to 20 September. And SDG Action Zone is between 22 and 24 September. So there are several programs throughout the month where you can engage with. And you need to post, like as part of our network, we post several posters around these issues or areas. And here I'm very proud that we have 700 coordinators in 101 countries with all our channels and the followers in our various social media channels increasing gradually. And I would also like to remind that though this is an old diagram, we have substantial capacity to contribute to the main 4 areas of SDGs, that is economy, society, biosphere, and partnership. And so you must engage and invite others to engage with this network. And also you must go out to the external networks and contribute to the common good. I'm still voluntary positions. If someone is interested in contributing in blogs or Slack, helping me with Slack channel or YouTube channel, then they are welcome to do so. Please approach me directly. These are voluntary positions. There is no pay. And there is no skill needed. I will help you to grow on this. And so today we have several speakers bringing in various knowledge on various areas. And so I'm so excited about this, to listening to them. And we will start with Mac Castle, who will introduce us with Axis app. And he will also talk about one question which would make this workshop interesting. So let me see if he is present here.
Good afternoon, Dr. Thakur.
Oh, wonderful. Here you are.
Hello. Hello, everyone.
I will stop sharing, and if you want to share your screen, you're most welcome to do that.
Wonderful. What I'll do is I'll start with a bit of an introduction first, if that's okay. So good afternoon, everybody. I'd like to start by thanking Dr. Thakur for inviting me along today. It looks like there's some really interesting speakers, and I'm really excited to hear about all the great work that they're doing. As Dr. Thakur said, my name is Matt Castle, and I'm head of engagement at a company called Axis. Axis is an easy-to-use, inclusive collaboration technology, and we work with lots of different organisations like top 100 consulting firms, multinationals, charities, community groups, networks, and SMEs. And we aim to harness the power of inclusive collaboration, design thinking, and agile to help organizations collaborate with more impact, innovate better, solve problems better, communicate better, and strategize better. And our core focus is on helping individuals and organizations address the big picture issues of sustainability and diversity and inclusion. So Dr. Thakur has asked me along today to run a simple exercise to basically take the pulse of the network and see how we can address sustainability through both collective and individual actions and at an individual and collective level. So what we're going to do is we're going to run an exercise throughout the session. And the idea is that you can put your input in at your leisure, and then we can share the results with everyone after the session. And hopefully the fantastic speakers that we have today will inspire you with some great ideas. So in the first half of the session, we'll be asking you for ideas around how we can address sustainability issues at an individual level. And then in the second half of the session, we'll be asking you for ideas around how we can do that collectively and as a group. So if I bring up my screen. I'm going to try and share just now. I seem to be having a bit of an issue with the share. That could be a problem. Bear with me just 1 second. Not sure why, Dr. Thakur, but for some reason it's not letting me share.
Let me see.
Yeah. What I could potentially do is...
It says one participant can share at a time.
Yeah. It's
and I'm not sharing, so you should be able to share.
Yeah, it's coming up with a not
all participants.
Yeah.
It is saying all participants.
Okay. What I can do, Dr. Thakur, is potentially pass the ownership of the workshop to you, and then you can get it up on your computer. Would that work?
Yes. Let us see how we can do that.
Let me see. See if I can share that. I seem to be having technical issues. I'm very sorry about this. I can't seem to share that either.
Okay.
Bear with me.
Maybe we can start the first presentation. Whenever you are ready, you can do that.
Yeah.
You can stop us.
I'll try and sort this out. If you want to start the first presentation,
sure.
I'll try and sort this out at my end, and then I'll let you know by Slack or something when it's sorted. Apologies.
Sure. Not to worry.
Thank you. I'll try and sort that out now.
So, okay, so we had James first, but James has already mentioned that he's having some problem with his internet, and so he will try later. So I invite Simon Perry to present his presentation. Is Simon here? Simon, would you like to give your introduction first, and then you can talk about your presentation? So over to you, Simon. Okay, we do not have Simon yet. So we will wait for him to arrive. Okay, we have Tina here, and I have seen Tina already. So yes, Tina, are you ready? Tina is evaluation practitioner at the Canadian Evaluation Society, and her areas of focus in international development are development, decent work, and using development evaluation as a tool for innovation and empowering marginalized communities. So she will bring her research here. So I will allow her to carry on with her research. Yes, Tina, you're most welcome.
Thank you, Dr. Thakur, for introducing me, and thanks for, being a part of the network, and thanks for that lovely introduction. Could you allow me to share my screen?
You can try, probably you will be allowed. Yeah, can you take the slideshow? If you go down the panel, yes, exactly. Good.
Thank you. So my broad topic for today's presentation, presented to the Global Sustainable Futures Network through partnership, is building evidence for innovation. And my topic is how to use developmental evaluation to build evidence for innovation. And I'm looking specifically at the case study of the Nova Scotia Works Diversity and Inclusion Program in Canada. So before I get into the findings from the project elements, it's important to introduce you to a basic overview looking at 4 important points. So the Nova Scotia Works Diversity and Inclusion Program is a Canadian $2.5 million program that was funded by the Nova Scotia Department of Labour and Advanced Education in Canada. So the original conceptualization when program partners came together started in November 2018, but in terms of the official launch, getting it off the ground, that was done in 2020, which is last year. The whole purpose of the program, it is focused on improving employment services and labor attachment for underrepresented groups. So one of Canada's strengths, and Canada has been heralded for its commitment to diversity and inclusion for racially visible minority groups, whether it be First Nations people, persons of African descent, African Nova Scotian women, people living with disabilities, older workers, immigrants, or newcomers. But this specific program, because it's a small scale program that grew out of a larger program, the focus is on African Nova Scotian and persons of African descent because they make up the largest visible minority population in Nova Scotia, Canada, and they're underrepresented in the career development sector. And by focusing on diversity and inclusion, the system will be able to better reflect the communities that it serves. So I'll move on to some of the core program elements. So first, it's about using research learnings from demonstrated projects across the province. And that major project was called the NOW program, New Opportunities for Work. That was large scale. It was a $10 million program looking at 6 underrepresented groups to get them internships, and then they would be permanently attached with the employer that they're matched with. The second is assisting employment service providers through training support. So there's a cultural competency training. So it's not just giving you training to work with anybody, but the specific group that an employer gets, they have a cultural competency training program. The support of hiring 16 African Nova Scotians or persons of African descent. And 4, having a culturally relevant training and mentorship program. So it's not just about hiring persons, or you get your first foot in the door, but those persons, they are appointed mentees to help them in their career development, not in the short term, but also the long term. And number 5, it's about leading a communities of learning to identify emergent issues and reflection. So for many of us who have worked on projects, we are accustomed to hearing the term community of practice, but we have decided not to call it a community of practice, but instead communities of learning, because it's a more informal space where the community, the participants of the program get to interact with stakeholders and to share what is it that is working, what is not working, and where is it we need to go with this program. So some of the program partners are the Nova Scotia Department of Labour and Advanced Education. That's the main donor. The Centre for Employment Innovation, that's where I had worked as a research coordinator for 5 months on the program. And the Nova Scotia Career Development Association. They are responsible for the career development sector, the mentorship, spearheading the mentorship component of the program, and 30 Nova Scotia work centers that were selected based on a criteria in terms of community need, representation, and so forth. So, and this is a meat of the presentation. What is a developmental evaluation? So most of us who have experience, working on different projects, at some point we have to do an evaluation to find out what is working. But there is something unique about a developmental evaluation. It's an evaluation method that is used in context of innovation, to support adaptation and learning. And some of the main principles is number 1, the design and implementation of a developmental evaluation. 1, is flexible and it is not rigid. So most of the projects that we work on, donors have a very strict timeline to say, oh, you need to develop your program, and by this date it should be done, and you present your project findings. With a developmental evaluation, there's a high degree of flexibility because you're working in an unpredictable context. And the perfect example of unpredictability is COVID. So you may plan something today and an event has to be put off because you don't know what may happen in terms of the news. You don't know if an event may have to be canceled. Another exciting part of using your developmental evaluation, it is user focused and not product focused. So it is primarily focused on the community that you are serving. It's first voice, it's participatory. And there's also the learning component. So it's not just about, producing concrete results. X number of persons participated in the program. What have people learned and how are they applying what they have learned? The role of the evaluator in a developmental evaluation is not necessarily an external consultant coming in to do the evaluation. The evaluator is actually embedded in the program, an active part of the project's design and conceptualization and implementation. And with a DE, it never truly ends. So even though you may present your project proposal or your project report to your donor, it's something where the learnings and the findings, it keeps on going even when it is ending. So those are some of the unique things about the developmental evaluation. So here is a checklist for those of you who may be interested in using a DE, and it's a checklist that our organization has used for the project. And these are the questions that you use to guide you. What is driving the innovation, right? So innovation is a key component. What is it you want to innovate and what is driving the innovation? Are the proposed innovations aimed at deep and sustained changes? So for people who want to make a change, and that's what this network is about, sustainability, the SDGs, being champions of sustainable development. That's an example of an innovation aimed at deep and sustained changes, and it's the same thing we have done for the project. The next question you have to consider, do we have a collaborative relationship with another organization in which there is innovative potential? In other words, is there a shared mission with another company or organization? And is innovation a part of your organizational culture? In other words, are you open to change? Are you open to doing and seeing things in a different way? If you are a bit hesitant and you like things the way they are, a DE may not be appropriate for your project or what is it you want to do. Then you have to think about what are some of the elements that you do not want to change as it relates to your organizational culture. And then last but not least, and I think it's very important, is it clear for whom the evaluation is intended? Is it specifically for a donor? Is the donor open to using this kind of evaluation method? Those are some of the questions that you could use to guide you to determine whether a DE is appropriate for your project, and we have used this for our project. So now into our findings. What is it that worked by using the developmental evaluation? So we found our method of using the DE, we did document reviews, we did focus group discussions, interviews, the communities of learning, but instead of having it face-to-face, we had a virtual communities of learning, and this is what really worked. Digital delivery of career services and programs were an important momentum for innovation during the pandemic. So a lot of the services were offered face-to-face where people could walk in to get resume building, career counseling tips from the employment service providers. But now with the digital shift, we are recognizing that there is an emerging focus around social justice issues, particularly how to get decent jobs to underrepresented groups. And there's a lot of innovation that took place. As a matter of fact, some of the centers were leaders in digital delivery of career services, and they were able to not just diversify their system, but also make it fair and inclusive for workers. Another important finding was alternative forms of recruitment and hiring approaches were utilized to promote diversity and inclusion. And this is a unique model to Nova Scotia in career development. We call it recognition of prior learning. So instead of selecting person on the traditional criteria of an advanced degree, such as a master's, a PhD, or 5 to 10 years experience, to give them their first foot in the door and an opportunity that is equal and inclusive, we also look for things such as volunteer experience, community experience. What is it this person has done before? Nobody comes into an institution or an organization as a blank slate. So that's what recognition of prior learning is. What is it you already know and what is it you can do? Another interesting finding is ongoing staff support. There was succession planning and cultural competency training for employment service providers. And in that big package too, there was also discussion around wage support for the workers who have been hired, the 16 persons who have been selected. And that wage support includes things like childcare, maternity leave, very important things in terms of providing fair and inclusive working conditions. And there was also partnership between community leaders and the centers to promote decent work. And then the mentorship program, they are paired with more experienced persons who are already in the system to say, listen, I have gone down this road before. I was unemployed at a point due to systemic barriers, but because of the opportunity inside, this is how I have advanced, and I am going to pass on my knowledge and experience to you. So the mentorship program was successful in terms of its rollout. And with a developmental evaluation, you have to speak truth to power. It's not just about what worked well. You also have to focus on what did not work. What were some of the weaknesses in your program? And these were the 4 things we picked up. The pandemic posed a challenge for remote transitions to work for both employment service providers and communities in rural regions. So the rural regions of Nova Scotia, they were at a serious disadvantage because of lack of access to, limited technology. The timing for recruitment and hiring process, it took longer than expected. There were delays in the recruitment and hiring process, and that led to delays in the timelines for the mentorship program. There were misinterpretations from the beginning about phrases used in job postings, such as a designated position. And there is also strong feelings of mistrust among African descent communities towards diversity and inclusion initiatives. So there's this mistrust on the side towards government. And in terms of generating some of the lessons for the next phase of the program, which started in March of this year, is to how to use a hybrid format for working arrangements to bridge the urban-rural gap, formulate a virtual engagement and in communities of learning strategy, seeing that we can't meet face-to-face to look at what is working and how and why. Designing a mentorship program in a way that meets the varying levels of knowledge for mentors and mentees. So everybody comes in with a different level of skill. How is it you can meet a program develop a program that is comprehensive? Also, if diversity and inclusion is the broad goal, how are we assessing that the program is actually not just meeting its target, but achieving its purpose? So we have decided to recommend coming up with accountability assessments for employment service providers to ensure that they're actually walking the talk. And then we came up with a system of monitoring and evaluation to track the progress and outcomes of how mentor-mentee relationships have developed over time, and what are some of the winning or success stories from those relationships or partnerships. This is the end of my presentation. Thank you.
Thank you very much, Tina. Thank you. Wonderful presentation and lots of lessons to be learned here, isn't it? And the most interesting part is that education can be coming from voluntary positions, community learning, and many other things rather than just institutional. And we give so much weightage to institutional learning and forget about all other informal learning. And also a very important message is walk the talk. That's very important. Thank you. Thank you very much. Do anyone have questions? No, that's fine. Thank you. And now I will share my screen to see who's next. And so next we have Wasim Sajad from Pakistan, and he's going to speak on circular bioeconomy. So I will stop sharing, and Wasim, please take the floor.
Hello, thank you, Ronika, for providing me the opportunity. So let me share my screen, and I also like to switch on my video. Just a minute. Sorry. Okay, so is it visible now?
It is visible, and you can try to put it on and let us see if the voice is also clear. So I will make sure the voice is clear.
Okay, so
okay, are you presenting? I thought you.
Today I'm just going to present. Yeah.
Okay, good.
So the world is now curious to move toward the sustainability, and also like to also take care of the consumer perceptions, because the consumer want to like use more natural and greener compound or extract or whatever we can call. So I just want to present here the idea of the circular bioeconomy. That what circular bioeconomy is basically. So in this slide, I just presented some of the photographs that's like moving from the water toward the desert. We need to explore the nature, and everything is already present here in the nature. We just need to explore. Yeah. So first of all, what innovation means to us. I think a lot of people like is telling the innovation that it's like creating something new. But what I believe that is just biomimicking the nature. Everything is present in the nature, and we have to just explore it. If we can talk about like the aeroplane and also about the bullet trains, so the concept come from the shark fish, and they design these aeroplanes and these bullet train based on those same design which they adopted from the nature. So So nature has spent millions of years in refining, and just we need to explore and just need to mimic the technology, integrating the technology in the biology, and we can produce like these commercially viable products through the circular bioeconomy. Later, I will present the whole concept. What is circular bioeconomy? Initially, just want to focus on some of the examples. So why we are moving toward the sustainability and why we are moving toward the green and natural product if we are talking in the science. So that is differentiating the product from the rest, adopting the market changes, and also aligning to the consumer perception and consumer demands, and also reducing the cost. And we can now the world is much more focusing on making the product more environment friendly and obviously sustainable, which is one of the key elements of this, the global sustainable future network. So this is a termite building. So in the Sdgs building, an office complex in Harare, Zimbabwe, has an internal climate control system, which was originally inspired by the structure of the termite. So I just here presented these examples that everything is here in the nature, and we just need to like explore the environment. We just need to explore the nature. If I'm talking about the biomass and its conversion to the valuable product, because every year 25% of the fruit and vegetable produce are lost or wasted because of the fungal spoilage and other issues. So we can convert these biomass, which is a rich source of the carbon and lignocellulose. So that can be converted into valuable product with the help of a biorefinery, which is a new concept in the bioeconomy or the circular bioeconomy. Like converting these sort of chemicals, these sort of biomass which are leftover or the leftover agri-mass to the valuable chemical compound and sustainable product. That is what we call the circular bioeconomy, which is like, I think, is a win-win situation, and not only clean the environment, but also we can produce something interesting and come up with some innovative solutions. So here I presented one of the example in the textile sector. If we are talking about circular economy concept in the textile sector, so the world apparel market is predicted to touch the US 2.6 trillion by 2025, and the growth projection of 2%. And textile sector is one of the main sector which contributing to the pollution towards the environment, and also the toxic hazardous chemical and toxic dyes, which are the petrochemicals, which can also pollute the ecosystem or fish and other seafood. And now scientists are very much focused on the blue economy. We need to explore like the seafood as well, because there's a rich source of the proteins and other amino acids. So now in the SDGs also focusing on the zero hazardous waste. And now the consumer, what the dye shows that like we can produce, learning from the coral to create colorful textile. That is another concept in the circular bioeconomy, because consumer want to use the eco-friendly products, and also this sustainable bioeconomy or the circular bioeconomy creating new opportunities and the sustainable manufacturing. So these are like the key facts and the key elements, and also some of the areas that I just want to focus on exploring to move toward the sustainable bioeconomy and circular bioeconomy. What I link this slide is towards the bio-waste of the fruit industry. So they extract just only the juices, and what the leftover behind that can be used as a biorefinery. And these biomass can be used for the extraction of the valuable polyphenols, compounds, and other cosmetics. And the skin market is accelerated sharply in 2018 and boosted by the expansion of the upper and middle classes all over the world, and especially in the Asia. And obviously, because the quite huge use of the social media, people look like to look good, to look smart. So the consumer also want to consume on the cosmetics, and they're more like obviously they want like to look good. So these fruit or these bio-waste can also be converted with the help of biorefinery into the valuable compounds in the cosmetics and sunscreen. So some of the key players I have mentioned that they are doing such stuff, and the pie chart shows the Unilever, L'Oreal, and other companies that are contributing towards the cosmetic globally. And now through using the power of biotechnology or technology when emerging in the biology, we can use the power of technology, and we can use sustainable textile clothes. We can produce sustainable pigments, sustainable dyes. Obviously, this is the concept of the natural plants. We can extract some of the dyes from the plants. And this slide I just mentioned about that is a major concern nowadays in the textile sector. That the greenhouse gases that are emitted from the textile sector is 1.2 billion annually, and every year there is like climate change. There is 1 degree centigrade rise in temperature. So the world is now like due to the climate. The world is like more obviously focused to come up with some innovative solutions and providing the natural resources and the greener resources to cope these problems globally. If we look here in this picture, there's quite huge use of the petrochemical and the dyes. In the left one, they are obviously going to mix with the marine and other water resources, and ultimately they can affecting our seafood and all the stuff like that. So yeah, obviously textile dyeing is the second largest polluter of the clean water globally after the agriculture. These are like the problems, and we can now come up with a collaborative approach by using these industrial waste, agrobio waste, biomass, and using the power of microbiology. With the help of technology, we can engineer the fermenters, or we can engineer some sort of tanks, and they can use these agro waste or the bio waste as a source of carbon, and that can be converted toward the bio-based chemical, bio-based enzymes. If we now the industries are much more focused to produce bio-based dyes in their denim finishing, because there is not only concern of the dyes, but also concern of the quite huge amount of water being used. And obviously, the world is already suffering due to the crisis of water. So the water table is already like down. So this approach will not only clean the environment and reduces the carbon dioxide and water, but also can save much of the water and energy as well. And in this way, we can lead to a sustainable research and innovation. So that is the overall concept of the circular bioeconomy, that how it works and how we can approach towards whatever the product is. We just need to design our own microbes, our own technology, and implementing those technology, we can produce the expensive chemicals, which are much greener and much safer and much biodegradable for the environment and for the people as well. So in the another slide, so I just showed here some data that if this type of technology is applied in the textile sector, so what we can get ultimately, what will be the result, or what will be the output or its impact. So it can cut the production time like 20-25%, because there is a quite huge processing in the textile sector, and it require like energy, and energy what is also already facing like the energy crisis as well. So we can replace the harsh chemical, and 1 ton of the carbon dioxide can be reduced, and also the water can be reduced to 70,000 per liter of the water can be saved per ton net fabric if we can use the bio solutions. We can also improve the hand feel, washability, and appearance by using such type of technologies. And another study showed that if all cotton t-shirts produced in the world last 20% longer, it can save 24 million ton of the carbon dioxide per year, and also can save 27 billion cubic of the water per year. If we talk about the dyes, so the indigo dye, which are quite hugely used in the textile sector from the petrochemical, if it could be replaced with the natural dyes, so it can also reduce 92% of the water, 87% of the cotton waste, and 30% of the energy. So it's like a win-win situation, not only to clean the environment, but also we can reduce our expenses as well. So in this slide, I just mention about some of the microbes, that how it works. We can design the microbial pathways using computer simulation, and through metabolic engineering and synthetic biology, and now the concept of artificial intelligence and the big data. Through biotechnology or the microbial metabolic engineering, we can design the microbes, the desired microbes, and converting these bio-waste or the biomass towards the sustainable and a good end product for the consumer. So this like the whole thing work, that how to design. Obviously, it needs some expertise, and it's not only about biology. Now the dimension, the paradigm shift, that we need to involve the mathematician, we need to involve the environmental biologist for the fermenter design, and obviously the biologists and other social scientists. So like it's a combined effort, and we can find the green enzymes and unique enzymes and efficient enzymes by adopting the right technology and finding out the right gene. So in this way, we can produce, we can less harm the environment, and we can produce the product with a greater efficiency, with the lower cost and lower energy consumption, and that can ultimately and obviously enhance the product properties. Or quality could be improved with the high yield. And through this joint effort, we can move towards a better and cleaner industry. So that is like overall concept of the circular bioeconomy. So hope like it's something like obviously some of you guys have always almost familiar with the bioeconomy and the use of the biotechnology. So that's all from my side. Thank you so much. Due to shortage of the time, I just went quickly. So if you have any question, I would be happy to address this. Thank you so much.
Thank you so much, Wasim. Wonderful, wonderful. Can you stop sharing your screen?
Yeah.
Thank you. And I must congratulate Wasim again, because due to this presentation, he won runner-up prize in SRI 2021 conference, isn't it?
Yeah, thank you. Yeah, that is the same idea. I just modified a little bit for the.
Yeah, he presented in a video form and as an idea, concept idea, and it was wonderful. He presented there in a video. So
yeah,
thank you very much, Wasim, to bring this and just putting everything together in a very speedy way, but still very informative and like understandable way. So thank you. And I think yes, multidisciplinary is the way we want to go, as well as connecting with nature and knowing the nature.
Yeah.
Need to explore nature's like there is immense opportunity in exploring the nature, and that is what we need, or everyone need to do, isn't it? Thank you very much. Wonderful presentation.
Yeah, pleasure. Thank you.
Okay, now let me share my screen and see who's next. And we have Matt Castle here again, and he's going to introduce us an idea of his this Access app in relation to gender equality. So I will stop here and I will ask him to share if he can. Would you like to try again?
Dr. Thakur, I seem to be having issues with my technology, unfortunately. So I've tried to sort it out, but I seem to be having some issues with the tech stack at my end. I'm really sorry.
Without sharing, you can just speak about your app. Maybe we can look forward next time.
So as I mentioned before, I work with Access, and we are an inclusive collaboration technology. And one of the key focuses we have is on diversity and inclusion. So one of the ways that we do that is when we were developing the app, we developed it with a number of different academics that worked in sort of group psychology and group think. And we asked them why collaboration in business seems to be broken. There was actually a study by the Harvard Business Review that estimated that 71% of all collaboration sessions that they observed over a 2-year period with 2,500 businesses were basically pointless. So we asked the academics that we were working with when designing Access why that 71% existed. And they basically said 2 reasons. Firstly, when you have a collaboration session, it's very dependent on the skills of the facilitator. So you want someone that's really knowledgeable and knows how to put a session together and run it so that they get the best out of the group and make sure that everybody's voice is heard. But the other one is group dynamics. So everybody's been in a meeting where you can see sort of 20% of the people doing 90% of the talking, and therefore the quiet expert in the room gets missed. Introverts don't feel comfortable chipping in. Women and minority groups tend to get ignored or talked over. Everybody starts following the senior person in the room, so following the boss. So hierarchy kicks in. Everybody starts trying to put up ideas that are similar to everybody else's. So you get negative groupthink. So we decided to iron all those problems out and take those issues away. So we went with our exercises that we have embedded in our system. With each one, at the beginning of each exercise, it has a similar format in that you will put your information in on your smartphone or an internet-enabled device. And once you put your information in, and the reason we designed it for smartphones is everybody's very comfortable with their phone. So therefore, they're very good at putting data in quite quickly. So you can generate a lot of data for each idea quite quickly. And everybody's always got their phone on them and they're very comfortable with them. And the phone comes with lots of functionality. But as I said, it also works with any internet-enabled device. But when participants put their input in, and unfortunately, I really wanted to demonstrate that today, but I'm having some technical issues at my end. But when they put their input in, their input is then anonymized. And that's a really important element, because then that means that no idea is seen as a bad idea. Nobody knows whose idea is whose. So you don't try following the boss or anybody else in the room. And you get true innovative freedom of thought. So everybody puts in their ideas in a very safe way. So because of that, we got approached by Innovate UK, which is a government department in the UK that decides where innovation funding is spent by the government. And they gave us 2 large bits of funding to work on how to make collaboration, especially in the business context, more diverse and more inclusive and actually more sustainable as well. So I've started with the diversity and inclusion section, and now we're moving on to the sustainability section. But with the diversity and inclusion section, we have linked up with lots of experts in different areas of diversity and inclusion. So LGBTQ plus acceptance and inclusion, gender parity in the workplace, disability, social and economic mobility, etc. And we've released a series of 5 templated workshops, and they are free for anyone to use. So you can be an individual, you can be a community group, you can be a network, or you can be a multinational. And you can also use our software for free as well to run those sessions. And that will really allow you to supercharge your diversity and inclusion agenda, either in your group or as an individual or as an organization. So the thing I was going to talk about today and demonstrate was the gender parity workshop. What I will do, rather than demonstrate it, is I will put a link in the chat so that you can actually access that free workshop template and our software. So if anybody wants to try it, run it, you will get access to it. And if you have any questions or you want to know more about that, you can also get back to me and I'll put my details in the chat as well.
Thank you. Thank you very much. Yes, you are please welcome to do that. And also, I would like to remind everyone that whoever we are having such problems like of internet access or electricity elsewhere in the world and so on, and sometimes people who want to present cannot present. So I will take this opportunity to remind you that we always encourage recorded presentations are also acceptable. So in your free time, please record your presentation and send us, and then we can play them here. So that can also be done. So if you have such problems, you can record what you want to speak, and then that would also help. Okay, it's not specially for you, Matt, but many of them, like just today, we had Simon and James who are having problems, and they are writing me that, oh, we have a very, we have problems. Then they should get into local recording and send the recording maybe, which would be helpful. Okay, thank you very much for presenting this. And I think this is so much important that it would allow everyone, like everyone should give a try, and it will change our, I think, the way of doing work and disseminating our work like to the outer external world. You know, it is very important that we include everyone's idea, and everyone, like inclusivity is very important for sustainability. So thank you very much for sharing this with us. Okay.
My pleasure.
See now who is next. Okay, we have Daniel to go next. Is Daniel here? Let me just check. Okay, I don't think Daniel is here, so we will go to the next one. And here we have next is Kushal Adhikari. And is Kushal here today?
Yeah, I'm here.
Oh, thank you. Thank you very much. So I will stop sharing and you can share your screen.
Okay, sure. So is my screen visible to you all?
Yes.
Okay, so good morning, everyone. It's just morning over here where I am. So I think it's somewhere afternoon, somewhere maybe already it's about to be a night. So good morning, good afternoon, good evening, everyone. I'm Kushal Adhikari. So I think my presentation is a little bit longer. So just to avoid that you maybe feel bored, I'll just start with a brief background about me, where I am and who I am. So I'm originally from Nepal, and it's my hometown, my home, where I was born and I grew up. And then I went to India for my undergraduate in civil engineering. I was there for 4 years pursuing my undergraduate degree. Then I came back to my home country and worked as a water resource engineer for almost 2 years. And then I came to United States at Texas Tech University to pursue my master's and PhD. And I recently graduated with my PhD degree in August 2021. And I joined Humboldt State University in California as a faculty in the Department of Environmental Resource Engineering. So I'm currently in California. So today I'll be presenting my research on water sustainability, and the title is Water Sustainability Using Pond-in-Pond Wastewater Treatment System, an alternative system for reuse that I proposed during my PhD dissertation. So this is the research that I'm presenting today is the one that I did as my PhD dissertation. So I'll try to summarize the findings from my dissertation today. So to begin with some global concerns, we have the limited freshwater resources. On top of that, we have the increasing population and the increasing food demand to meet the needs of growing population. On top of that, we have the changes in the climatic factors that has created additional stress on water availability, thus leading to water scarcity across several regions of the world. So this is data from Food and Agriculture Organization, and it shows the per capita water supply in different regions of the world over the last 3 decades. And here we can see for almost every regions of the world, we can see a very huge decline in the per capita water supply. And except if you look at these numbers, the only country where the per capita water supply hasn't declined very significantly as compared to other regions of the world is Japan. And it's because they have very strong reuse strategies and they have been very effective in reuse and reclamation of the wastewater. So let's see where we are using our freshwater resources. And looking at the data, it's mostly municipal, consisting of public supply, domestic use, and agricultural, which includes irrigation, livestock, aquaculture, and the industrial, such as the mining, thermoelectric power. So municipal, industrial, and the agriculture are the three major sectors where our freshwater is being consumed. But from all those sectors, we have a huge portion of water consumption that comes out as a waste, which we call generally the wastewater. And looking at this data, or the pie chart from Food and Agriculture Organization, again, we can see that the big two chunks represent the agriculture water consumption and the waste that comes out from the agriculture practice. So the black one represents the actual consumption in the agriculture practice, and the 32% in the blue represents the waste that comes out from the agriculture practices. Likewise, we have 11% for the municipal consumption, of which only 3% is actually consumed and 8% comes out as the wastewater. Likewise, for the industrial, we have 3% that is actually consumed and 16% comes out as the wastewater. So in total, from all the three sectors, we have around 56% of the global freshwater vehicles coming out as the waste. So the goal of my dissertation here was, if we would be able to use some portion of this wastewater to use in irrigation or to meet the agricultural needs, we'd be able to save a huge chunk of freshwater for other uses. So you can see here 70% is used for agriculture. So our goal is, if we can bring this 56% and reuse it for meeting some portion of the 70%, then we could save the freshwater for the human consumption and for the future years to come. However, only 6% in the US and less than 3% globally is reclaimed for beneficial use. And we looked into the data and we projected, and if the recycled rate could be increased to 15% as compared to what we have nearly around 3% currently, we'll be able to save the freshwater up until the year 21-25 instead of the 2030. So the overall goal of my dissertation, this research, is to develop a simple, low-cost, adaptable wastewater treatment system that can be used for wastewater reuse in irrigation. So to discuss on why the reuse in irrigation has been a focus in this research is, first of all, as we saw, 70% is used for agriculture practice. So if we have alternative source to meet that needs, we'll stress on freshwater resources. Also, reuse of wastewater and irrigation, we have the standards of the effluent quality much less stringent compared to the stream discharge. So it will help us save a huge amount of cost in the treatment of wastewater. The next key factor is, if the wastewater was used for some household practice, the public, there is very less social acceptance and public acceptance. But if it is used for irrigation practice, then it is observed that the public will be more acceptable as compared to other household practices to use the treated wastewater. So another key factor was the public acceptance, and reuse in irrigation has been commonly used in several regions of the world now to meet the water scarcity or to address the water scarcity issues. And there are some other advantages of using wastewater effluent in irrigation, because it's readily available and produced at the proximity of demands for crop production, and it supplies the nutrient-rich water for the irrigation, thus avoiding the need for commercial fertilizers. So to use the wastewater in the irrigation or for the agriculture practice, first we need to treat it to a certain level. And there are several different treatment systems designed for treating the wastewater. However, the key focus on this is the ponding systems, or the natural wastewater treatment systems, as they are the simple, low cost, and the low energy treatment system. And as you can see on the figure on the right, there are mainly three different types of pond systems: anaerobic, facultative, and the aerobic or the maturation pond, depending on the pond geometry and the biological activities going on in the pond. And to design this different pond system, again, there are multiple design approaches and different design methods which are in practice, and each of them have their own limitations and have their own merits in adapting for the design of the pond treatment systems. So as a first part of the research, what we did was we looked at all the existing design approaches and we tried to see where the gaps are or what the similarities in all those design approaches are. So while observing that, we came to a conclusion that there was no agreement on the pond configuration required for optimal performance or the optimal treatment of the wastewater. And it's mainly when compared to loading versus performance, the pond dimensions such as the depth, retention time versus the performance, and the pond configuration such as length to width ratios, backfalls, inlet outlet locations versus the performance. The next finding was we saw that there was a huge variation in the area requirements based on what design approach we take. So the table on the right shows the land area requirements for the pond system to treat the water to the same standard, but using the different design approaches. So the first column shows the different design approaches, and the last column here shows the land area requirements to achieve the same level of treatment. Here we observe that the land area requirements, depending on which method we take, it ranges from around 80,000 square meter to above 200,000 square meter. So through this research, we wanted to propose an alternative system for wastewater reuse, and which we call it the pond-in-pond. The pond-in-pond is simply a treatment technology that combines the aerobic and anaerobic unit into one, thus integrating the best functions of both the pond units. So as shown here in the picture, the right one is the pond-in-pond and the left one is the traditional pond. So the pond-in-pond has the aerobic surface at the top that helps in the photosynthetic oxygenation and also helps to control the odors. And the bottom section here is anaerobic, and here we can see as compared to traditional pond, the sludge is well protected here and there is no mixing of sludge with the water, hence it is well secured there for the more complete degradation of the organic matter. So this is the general layout of the design for the pond-in-pond. So the top shows the plan and the bottom shows the cross section. So we have the inner pond and surrounded by the outer pond, and this shows the cross section where we have the inner pond deeper as compared to the outer pond, and this is the recommended location and the recommended height for the effluent and the height of the pond. And this is a research still in progress, so these design parameters are just the recommended based on the existing knowledge, but this is something that we're still working on to come up with the optimal design for the pond-in-pond. So these are just the recommended based on the existing knowledge that we have. And there are mainly two key factors that we need to consider while designing the pond-in-pond. It's the inner pond configuration, the small deeper basin, which is the anaerobic unit. So here, the two key things are the volume or shape or area of the inner pond. So this, looking at different case studies, we'll be seeing in a couple slides next. So there are different types of different shapes or the different volumes has been used, but based on the findings, it is observed that the frostoconical shape as shown here has more benefit as it helps to reduce the off-flow velocity, because we have the influent coming here into the inner basin, and if this is in the frostoconical shape, the off-flow velocity, it helps to minimize the off-flow velocity, thus helping to settle the particles down in the bottom of the pit. And the bumps this is the surrounding the inner basin. So it has mainly two purposes. One, it helps to prevent the mixing of water in the aerobic zone with the water in the anaerobic, or helps to limit the effects of the wind mixing. And the other one is it also serves as the baffles or the barriers, so helps in proper dispersion of the wastewater within the pond. And the next is the pond depth and the orientation. So it's again, as I mentioned, this is still the research in progress, but the best knowledge, the recommended depth for the inner basin is at least 20 feet or the 6 meters, and for the outer basin is at least 3 meters or 10 feet. And the retention time for the inner basin is 2 to 3 days, and the outer basin is 20 to 30 days, depending on the weather and the climatic conditions. So we'll need to have more retention time in the cold regions, whereas the retention time can be relatively shorter when we have the warm climate. And the next is the length to width ratio. So it's typically 1:3 has shown to provide the best performance, but it's again, it may vary depending on several other environmental factors and other design parameters. And the location of the inner pond, so it is preferably located at 1/3 of distance from on the opposite end of the effluent. So, and it's located in the opposite direction of the primary wind direction. And that's mainly because, so it helps to avoid the short circuiting because we have the effluent in this direction. So we keep it in the opposite direction of the wind, so limit the short circuiting. And the next thing is it helps to the water to remain in the pond for a longer time, thus can achieve more treatment. And lastly, the inlet outlet location. So they are located, the inlet is located in the inner basin and the outlet on the opposite end at some 2 to 3 feet or around 1 meter from the surface. And it's mainly to prevent the floatables or the particles that are floating on the pond to exit from the effluent. So it's typically located around 1 meter down from the surface of the pond. So as a next step in the research, what we did was we tried to gather some pond systems that have very similar configuration to that of pond in pond, which we are proposing for the wastewater reuse. So we went back and looked for systems. And this is the advanced integrated wastewater treatment systems. And this was designed back in 1960s by a scholar, Dr. Oswald. So these are mainly designed for treating wastewater for stream discharge and consists of 4 different units: advanced facultative pond, high depth pond, algal circling ponds, and finally the maturation ponds. But here, the only concern of our research is the first unit, that is the advanced facultative pond, as it has a very similar configuration to the pond and pond. So we aren't concerned or worried about the remaining units, and we're just looking at how this unit alone was performing, and will this unit alone be able to provide the treatment level adequate for the wastewater reuse. So we went ahead and gathered the data, performance data for this system. So these are the 4 different systems that are in California. And this is the influent BOD going into the system. And the BOD is the biological oxygen demand, which is one of the key water quality parameters for effluent reuse in irrigation. So we have in the range of around 160 milligrams per liter to around 225 milligrams per liter. And this 3 columns shows the performance for the pond in pond, or just the first unit, as I saw here, as it's named as the advanced facultative pond. And lastly, the performance of the overall and the entire AIWPS system consisting of all the 4 units. So the first unit, looking at the performance of the first unit, we were able to see that it was treating almost on average of around 80% of the BOD was removed by just the first unit of the AIWPS system. And the effluent BOD was always less than 60 milligrams per liter, which is the preferred desired limit for wastewater reuse in irrigation. So looking at this data, we found that the first unit itself was sufficient to treat the wastewater that we could use now for the irrigation practice and avoid the additional land area and the additional cost for treating. So we have the additional energy here to keep this unit aerated all the time. And also this is a huge land area requirements compared to the first unit. So our goal was to see if we can just use this unit and use the wastewater for reuse rather than treating it for the stream discharge, thereby saving a huge cost and huge energy. So from this performance, we observed that the first unit was well sufficient enough to treat the wastewater. And this is the performance of the overall system. And we can see, yes, the overall system was giving much better performance, like from 17, we had 7, like it was an average of 80, but here we can see an average of 95% removable. But for additional 15% removable, we have additional land area requirements and additional energy. So our goal is just to minimize the land area requirements so that this pond-in-pond system can be used in any small communities or even in the cities with the limited land area availabilities. So likewise, this is a system from Ethiopia, a very similar system, AIWPS system, and this is a pilot study. This was used for treating the industrial wastewater. And this is the AIWPS system. The outer square is the outer basin, and the circular here is the anaerobic pit or the fermentation pit. So again, we went ahead and collected the data for this. So here again, this shows the performance for the pond-in-pond or the first unit alone. And we can see that again, the percent BOD removal is an around average 80%. But here, as I mentioned, this was treating the industrial wastewater or the tannery wastewater. So the incoming effluent BOD was much higher. So we still have the effluent BOD much higher, and it's not the adequate standards for use. But what we're looking here was even for the very high strength industrial wastewater, the pod input system was providing a BOD removal of around 80%. So if we could add one more unit so that we can reduce this to less than 60, then we'll be able to use the industrial wastewater also for use by the use of pond input. So this is the, again, overall performance for the entire system. And this is the another system that we looked, and this is in the Colorado City, Texas, and it has the 2 pond input units in series and the influent coming here, and the effluent is stored in a basin for around 2 to 3 days, and depending on the need, it has been used for the wastewater for the reuse in agriculture practice, and this has been there for almost over 15 years. And we gathered the data from 2010, as the city didn't have the data prior to this. So we collected data from 2010 up until 2019. That's the date when I was doing my research. So for the 10 years of data, we observed that for all the years, the effluent BOD was below 60 milligrams per liter, as shown by the red horizontal line, except for the year 2015. And we went ahead and looked the data for the 2015, and we observed that there were 2 of the data points which were more than 2 standard deviations of then the data that was there for the other remaining years. So we speculated that it was some error during the data collection, or maybe the city had some mistake during the reporting of the data. So just to see how that data has influenced our analysis here, we did the analysis excluding the year 2015 data and including all the data. So the gray bar shows all the years, and this is the y-axis is the effluent BOD, and this is the different months of a year. So with all the years, again, we can see that because we can see for the month of April, we have the data exceeding the 60 milligrams per liter. And it was, as I mentioned, that those 2 data points were in the month of April. So we excluded those 2 data points, and we tried to see the monthly average effluent BOD, which is shown by the white bars here. And we observed that for all the months, our effluent BOD was always less than 60 milligrams per liter. That is what we were looking for the reuse in agriculture. This shows the overall annual variability, again, effluent BOD on the y-axis, and all the years, the gray bars, and with the white, it's excluding the year 2015. So we can see that most of the data, about 50% of the data was around 40-45 milligrams per liter, and with very few exceeding the 50 milligrams per liter, but still it was below 60 milligrams per liter. And this is the monthly variability again. Here we can see all the effluent BOD values were less than 60 milligrams per liter when the year 2015 was excluded. But with the year 2015, we have some data that was beyond 60 milligrams per liter, and that was due to the effect of those 2 data points that we speculate to be an error in the measurements. So the other case study was in the Denver, Colorado. It's a very similar system as pond in pond. And again, this was obtained from the EPA report, and it shows the yellow lines represent the effluent BOD and the purple lines represent the influent BOD. So this is the influent BOD, and on the y-axis on the right, we have the effluent BOD. So we can see the effluent BOD, or the yellow lines, are much lower than the 60 milligrams per liter required for the wastewater reuse in irrigation. So to summarize the performance from different case studies, we observed that this plot shows the performance for the pond-in-pond systems treating municipal wastewater. The y-axis on the left is the BOD in milligrams per liter, and the right y-axis represents the percent BOD removal. The gray bars represent the influent BOD, the white bars represent the effluent BOD, and the black solid line represents the percent BOD removal. And on the x-axis, we have the different systems that we're treating the municipal wastewater. So we can see the influent BOD ranges from somewhere around 160 milligrams per liter to a maximum of around 260 milligrams per liter. But the effluent BOD was always less than 60 milligrams per liter for all the different systems that we looked at. So indicating these all systems were the only first unit which was very similar to pond in pond was adequate for treating the wastewater for reuse. And this shows the average BOD removal, that is around 80% of the incoming influent BOD. And this is the summary for the pond-in-pond treating industrial wastewater. So the very similar guidelines here, the BOD, percent BOD removal, and the different feeds, this was a pilot study, so they have the different feed. So we again observe here a very similar percent BOD removal that was around an average of 80%. So looking at the performance data, it was very motivating for us that it was providing just a single unit with a very simple design was providing the level of treatment that we are looking for. So we went ahead and looked into the land area requirements for the pond-in-pond compared to other pond systems that are in practice. So we came up with an hypothetical example with the influent BOD and the effluent BOD and some environmental parameters. So these were same for all the different pond systems during our design example. So we designed the different pond systems, the aerobic, facultative, and again, for the facultative, we designed using two different approaches, the Werner-Willem approach and the Gloena. These are the two different design approaches, and the anaerobic and the pond-in-pond. So here we observe that the pond-in-pond requires around 40 to 60% less land area as compared to other pond systems to achieve the same level of treatment when the same environmental conditions and the same influent BOD was used. So from here, we observe that pond-in-pond would be able to reduce a significant amount of land area, so which will help or which provides the feasibility of using pond-in-pond even for the cities with a limited land area availability. So as a next step in the research, we went ahead to understand the performance or the working mechanism of the pond-in-pond, or we wanted to understand more why the PIP or the pond-in-pond was providing that level of treatment, even with a very small land area. So we went ahead to do some modeling approach. So we did the 2D modeling on the pond-in-pond. So the top figure shows the pond-in-pond and the bottom shows the traditional pond. So the red indicates the 6 meters of water depth, that is the depth for the inner basin, and the green represents the 3 meter or the 10 feet for the outer basin. And we have the regular pond for the 10 feet or the 3 meters as indicated by the green color, and the blue color surrounding the inner basin is the bombs that I mentioned before. So just to surround the inner basin to prevent the mixing of water from the inner basin to the outer basin. So here we analyze the flow behavior in both the pond systems, the velocity pattern and the particle distribution in the PIP versus the traditional pond. So here we use the two different modeling approaches, sediment transport for river modeling, STROM, and the other one was the Telemark 2D, just to confirm and validate the results that we got from the modeling. So we use two different modeling softwares. So the top figure is for the pond-in-pond here, the bottom is for the traditional pond, and the color indication shows the velocity in meter per second, ranging from zero, like the blue indicates the lower velocity and increasing as the color goes from blue to the red. So here for the pond-in-pond, we can see that the incoming higher velocity dissipates within the inner basin, and for the rest of the basin, we saw a very low velocity profile. But in the traditional pond, we see that the incoming higher velocity propagates throughout the pond area. So we can see the more reddish or the yellowish color throughout the pond here in the traditional, but in the pond-in-pond, most of the region is the bluish, with indicating we have a very low velocity in the pond over here. Also to validate, as I mentioned, this was the first time we were using this software to simulate the pond system. So to validate our modeling results, we did using another software called the Telemark 2D, and this is the pond-in-pond and the traditional pond. So we were able to observe the very similar simulation results from both the softwares. So it validated our modeling approach. So here again, it shows that this high velocity or the incoming velocity was dissipated within the inner basin, whereas in the traditional pond, the high velocity was propagated throughout the pond area. Next, we look at the flow distribution or the velocity distribution in both the ponds. And again, we observe that in the pond-in-pond, we have the more uniformly distributed flow, whereas in the whereas in the traditional pond, we have a channelized flow. As we can see here, that the water was taking a path around the edges, just circulating in the pond, rather than the well-distributed pattern as in the pond-in-pond system. So next, the last we observed was the particles retention time. So again, the top shows the particle distribution and the particle movement in the pond-in-pond at different simulation time, and the bottom shows the corresponding particles movement and the distribution at the same times as shown here for the pond-in-pond. So what we did here was we introduced the equal number of particles at the inlet for both the ponds, and we observed how the particles move and how they get distributed in the pond over time. So this is at the very initial, at around 300 seconds, the 5 minutes of time, we can see that the particles were still in the inner basin, but in the traditional pond, we observe that the particles almost travel half of the pond length in the same time of around 5 minutes. And in around 17 minutes in the traditional pond, particles started exiting from the outlet. So the particles were already at the outlet side or the effluent side of the pond, whereas for the pond endpoint, it had just started to exit from the inner basin and had just reached the half of the pond length. And it took almost double the time. So it was 17 minutes and it was around 3600 seconds. So it was almost double the time here. So this is the time when we first observed the particles coming out from the outlet in the pond endpoint, whereas over that time, most of the particles in the traditional pond has already exited from the traditional pond. So from here, the key takeaway message was like in the pond endpoint, more particles tend to settle down in the PIP, as observed here, the density of the particles. But in the traditional pond, more particles tends to remain in suspension, thus reducing the chances for particle settling. Further, we gathered the data for the particles retention. So we exported the data and we did the same simulation with different particles size, like we tried with the 5 particles at a time, 10, 15, 25. And this is the number of time steps, total particles in. And this was the particles retained and the particles retained percentage for the traditional and for the pond endpoint. So for the traditional, this was the particles retained at 4 different simulations that we conducted with 5, 10, 15, 25 particles at the inlet. So we have around 60% of particles retained. For the pond endpoint, it was around 75% of particles retained in the pond endpoint. So we're able to increase by an approximately 17% of the particles retention in the pond endpoint. So with this, as I mentioned before, this is ongoing research I'm still working on, and there are other colleagues working on this. So we're currently working on integrating the new CFD model, the computational fluid dynamics model, with the biokinetics model. So the findings from this will help us provide the in-depth understanding of pond hydrodynamics and the biological process within the pond. And it will help us understand the solid retention time in the inner basin. So with this knowledge, we'll be able to determine the service life of the PIP and will PIP be able to handle the high strength waste. So we're trying to analyze if for now, we're now focusing on is PIP a good system for treating the high strength industrial waste as well. So that is where we're heading next. And the future prospect on this is to integrate the CFD model with the optimization model so that we can come up with the optimal design for the PIP. And also the findings could be used as a decision support tool to test strategies for multi-objective optimization of the PIP systems. So with this, I'd like to conclude my research. So from our findings, what we observed was the knowledge and design of ponds is inadequate. So we need to have an alternative system for wastewater reuse in irrigation. And we propose the pond endpoint system as a potential system for treatment for reuse because of its simplicity, low cost, and the low energy system. And also we look at the performance data, and it was providing the consistent and the treatment levels required for reuse. Hence, it might be a sustainable approach for reuse. So more investigation and more findings on the PIP would help address the major societal concern of water scarcity with low cost and effective wastewater treatment. So before concluding, so I'd like to thank my dissertation committee chair, Professor Clifford Felder at Texas Tech University, department chair, Professor Venki Shankar, and my dissertation committee member, Professor Theodore Cleveland, for their support on conducting this research. And my colleague Ali Reza Sadi, who was helping me in the last part of my research, and he was we team up in writing one of the manuscripts from this research, and my Department of Civil Environmental Construction Engineering and the graduate school for the funding required for me to conduct this research. And these are the 3 articles that have been published so far, and there are a couple coming up. So the first one is basically a review article that discusses the first section, what I presented today, where we analyze the different pond design approaches and look for the technology gaps and the limitations of the existing design approach. The second is basically it focused on the performance, where we looked at the different case studies. And the third article that has been published is mainly focuses on the modeling results that I presented today. So it discusses on the flow dynamics of the pond endpoint and why the PIP provided better treatment compared to the traditional pond. So apart from water sustainability, I'm very interested on the sustainability project. So I'm interested in any form of sustainability projects, and I look forward for connecting and collaborating. And these are the 2 areas that I'm still currently working and I have worked before. So the sustainable materials or the green cement. And these are some of the articles that we have published on this. So in this, the project idea is to come up with an integrated approach for green and economical cement production. So this is a perspective idea that me and my colleague has put together. So this is if this is of something interest to anybody, that I'm looking forward to continue this research. Like we have conducted a series of experiments, and from the findings, we have proposed a new approach for the cement plants, and we're looking forward to continue this research so that we could bring this approach in practice in real cement industries and help minimize the environmental impact of the cement plants. And the other one is the climate smart agriculture. And here my research effort is on developing sustainable adaptation strategies for the climate smart agriculture. So basically the dryland cotton irrigation, the feasibility of dryland cotton production in the limited water availability. So these are the two areas that I'm still working on. So lastly, I'd like to make some announcement. And since this is, I think this is a good opportunity to share. So I'm also serving as a guest editor in two different journals, the Discover Sustainability, along with Dr. Thakur and other the scholars from different regions of the world. So this is the Discover Sustainability, Springer Nature Publications. So here we are looking for the contributions from you all in regards to how sustainability education influences consumption and production systems and contributes to achieving sustainable development goals. And the other journal that I'm serving as a guest editor is the Resource, Environment and Sustainability, which is a Elsevier publication. And the special issue title is Water System Transformation and Sustainability Through Reuse Within a Circular Economy. So I request everyone, and it would be a great contribution if you are willing to contribute in either of those, depending on your research areas. So lastly, yeah, that's all that I have today to present. And thank you all for listening, and thank you all for your time. And thank you, Dr. Thakur, for creating this platform to share our research and connect with each other. So lastly, as being a young research scholar, I look forward to connect, collaborate, and contribute with you all. And so these are some ways that I can be reached out, and look forward to connect with you and collaborate with you in the future. Thank you very much.
Wonderful, wonderful presentation. And it was very in-depth research. And I think you have brought in multidisciplinary research here very effectively, showing biology and like a main disciplines combined together, and how we can do innovation also for nature-based solutions and so on. So yeah, wonderful presentation. Thank you very much for giving such this opportunity to listen to you.
Sure, thank you, I appreciate that.
Yeah, yes, it is really nice to have you here. Very pleased. So I think today we focused on innovation, inclusivity, and nature-based solutions, and many, many more things. But it was wonderful, like, to have this panel here. So let me share my screen now. And so future opportunities. One of them has already been told by Kushal, but I will go through these. So on 24th of September, we have engaged with climate fringe organizers, and they have organized Climate Fringe Week, which is between 18 and 26 September. And we will be delivering an online event, which is going to be on Friday, 24th September, between 2 and 4. We are inviting all our network coordinators to present here, and we will be selecting 24 speakers who will speak for 5 minutes and present their presentations, and make a link between like SDGs or climate change and global sustainable futures. I have already received 19 interest, and we are having a dry run on next Saturday between again 1 and 3 for 2 hours to finalize our session. It is only going to be 5 or less than 5 minutes each participants, but we want to give a flavor of how wide and varied our network is, and what we can bring to this world, and how we can engage with SDGs, climate change and global sustainable future. So you are all welcome to join. Also, it is going to be live on YouTube, and here you can, I have put the visit us. So that is for us, like whoever wants to join our network and so on and want to see our web pages. But here, join here will take you directly to the Zoom meeting, but it is also on YouTube, and I will be sharing the YouTube link as well. So, and I would like to remind everyone that please go on YouTube and subscribe our channel or like our videos so that we get some, it helps to spread our word. Okay. And here again, I'm just repeating what Kushal made his announcement here, that we have a topical collection, the role of education in the implementation of UN Sustainable Development Goals, how sustainability education influences consumption and production systems and contributes to achieving sustainable development goals. Though we have written here consumption and production system, however, it is quite wide, and you can bring in any areas of SDGs to relate and to be accepted for these. So the deadline is 31st of March, and this is why, this topical call is supported by me and Dr. Kushal Adhikari, as well as we are joined by Dr. Isha Alegble, Dr. George Hussain, Dr. Marvis Ali, and Dr. Eva Duda. So please contact me if you have any queries, and remember that you have this topical collection. So if you want to contribute there, because there are many opportunities of publishing here for free or low cost, and therefore you must engage with this us and see what are the opportunities here. And as I have mentioned, that why we have taken this topical collection to be published in March, because we are proposing a conference on annual conference, like we will be completing our 1 year, and it is the annual conference is on 10th and 11th. Here I have written 11th December, but I might go for 10th or maybe both days, depending on how we get the interest. And I am looking for others to join me as organizers, speakers, delegates, and we will be giving certificate of appreciation and participation to all the presenters who will attend and present or join us. So please get in touch with me, whoever are interested to do this. It is in a design state. So as soon as you approach me, it will be wonderful. 11th September is my husband's birthday, and I want to celebrate this birthday with the world and disseminate something that can be useful to the world. So I'm welcoming all your proposals. So please get in touch with me. And that is all for today. And you all know that we have social media channels, which is WhatsApp, Facebook, LinkedIn, Twitter, Instagram, blogs, Slack, Future Earth Circle. So please join them and be touching the network. So because many of all the events or calls, vacancies, or any news are spread through these social media, because we have stopped doing very formal newsletter. So engage with these social media channels so that you get news then and then, and you can make most of this network. So thank you very much for today's very wonderful presentation, and I will stop sharing here, and I will welcome any questions, remarks if you have. Yes, anyone want to speak? Anyone have questions for any speakers? No, all good. So I will stop sharing. Oh, yes. Hello,
Yeah.
Harman.
Hello, I'm back. Yes, I want to ask if I have some space for the presentation next time for the 35 presentations to do a presentation about waste gone without CO2 emission and matters and smell. Is that a possibility?
Is it for the next monthly seminar?
Yeah, or for the global.
A climate fringe?
Yeah.
Yes, sure. Please get in touch with me.
Yes, I will do.
Yes.
Thank you.
Certainly.
And I wish you a happy weekend and I'll speak to you soon.
Thank you.
All of the rest, same.
Thank you. I will stop the recording first of all.